Hi friends, welcome to the channel Unshackling Sudokus and Puzzles. Ashish here, and today I'll be covering a Sudoku variant called Arrow Sudoku on our channel. So there is a slight change in this rule on this particular Arrow Sudoku, that is instead of numbers 1 to 9 we'll be using numbers from 0 to 8. So this is called 0 to 8 Arrow Sudoku. So this particular Sudoku was featured in the recent Sudoku GP round. All the authors were Indian authors, and this particular Sudoku was constructed by Akash Doulani, one of the highest pointers in the round. There were two high pointers, and both of these high pointers were by Akash Doulani. This is one of the high pointers, and we got a request for this Sudoku to cover it on our channel. So I thank all the viewers for giving us a request for Sudoku or a puzzle on our channel, and thanks a lot Akash for such a wonderful Sudoku. I was also one of the authors for this round, so I actually know the solve path of this Sudoku. I solved it some time back before the competition. So yeah, let's see if again we are able to solve this logically or not. I don't remember much of the solve path, but still I remember some of it, and let's see if we are able to crack it again or not. And before going to the Sudoku, I would highly recommend you to please subscribe to the channel Unshackling Sudokus and Puzzles if you haven't done so. It will really motivate us to cover videos on regular basis. And if at all you have a request for any Sudoku variant or a puzzle genre, you can let us know in the comment below, and we'll surely make a video on it. And now coming back to this Sudoku. So classic Sudoku rules apply. You need to place digits from 1 to 9 in each row, each column, and 3 into 3 box without repetition. Apart from that, there are some arrows in the grid. The sum of the numbers on the arrow line is equal to the number in the circle, right? And the numbers are not 1 to 9, actually 0 to 8. Yeah. So with that, let's start solving this Sudoku. You can see box 1 and 9, there is a very good start here. So if I take all the minimum sums on these arrows, that is 0 to 5, 0, 1, 2, 3, 4, 5, the sum of all those numbers are 15, and the maximum sum that you can get on these two circles is 15, 7 and 8. 9 is not possible, it is only 7 and 8. So which means these numbers would have to be 0 to 5 in any order, right, according to what the sum you get. So which means these three digits are 6, 7 and 8, right? Okay. The same thing I can do here in the box 7. If I count the minimum sum possible, that is 0 to 7, no, 0 to 6, 0, 1, 2, 3, 4, 5, 6. Some of these 7 digits would be 21. What is the maximum sum that you can get here? So when the minimum sum total and the maximum sum total matches, then that's the only possible combination you can have in Arrow Sudoku. So the minimum sum total I have here is 21, and these three sums can only be 21, 6, 7 and 8, right? 6, 7, 8 is 21. So that means all these would have to be the minimum sum, and the maximum sum 7, 8 would have to be somewhere here, and which means these two cells would have to be 0, right? Amazing. Because you cannot have any more sums here, because this 21 is equal to this 21, there cannot be any more sum added here, and these two would have to be 0. So which means 0 would have to be somewhere here, and 0 would have to be somewhere here. One other logic is, if you have a 0 on this arrow, you cannot have 1 here, because if 0 and 1 are counted on the same arrow, to get the minimum sum at least 7, you need a 6 here, which is again not possible. We already have deduced that 6 would have to be in one of these three cells. So which means if you have a 0 on this arrow, 1 would have to be somewhere here. The same thing goes here. Now if you see a 6, 7, 8 and 6, 7, 8, which means 6 cannot be in any of these cells. 6 is in one of these two cells, right? Zero is not here, not here, not here, and not here. So which means this is 0. When you know that you have a 6 here and a 0 here, the only remaining digits would have to be 1 or a 2 to get the sum as 7 or 8. Of course, sum 6 is not possible. You already have 0 and 6 on the line. You will at least have 1 on the line again to get the sum at least 7 or an 8. and we know that 1 cannot be here on this because of the pointing of ones. Okay, so now comes the best part of this Sudoku. What tricked me during my solve was this point was the most trickiest point in this Sudoku. That I think was the what to say, the highest, that made it the highest pointer in this sum. These two sums will never be the same. So what is the sum that you can get on this circle? 0, 6, 7, 8 is not possible. 2 is also not possible. 1 is also not possible. It is either 3, 4 or a 5. The same thing that goes here. It has to be either 3, 4 or a 5. Right? Both of these cannot be 3. Both of these cannot be 4. And both of these cannot be 5 simultaneously. Because that would create a contradiction in the box 7, that you cannot have 3, 4 or 5, whatever be the case, if these both are same. Now what happens if any one of these two sums is 4? Let us assume what if this is 4? The only possibility for having this as 4 is 1 and 3. The moment you have that, both 3 and 4 would have to come here in this box because of the pointing of 3 and 4 in towards column 8, and both 3 and 4 gets eliminated from here. This would have to be a 5. Now we know that both 3 and 4 are here and 5 is here. This only would have to be 1 or a 2. The 5 sum gets contradiction. You cannot have a 5 sum here at all. In both the cases, if you have a 4 here, this is 1 and 3, both these would be 3 and 4, this is 5, and this would have to be 1 and 2. So which means this sum cannot be a 4 and this sum cannot be a 4. This is 3 or a 5 and this is 3 or a 5. Right? The 3 sum would have to be 1 and 2. The 5 sum would have to be 4 and 1 and 4. Why it cannot be 2 and 3? Let me show you again. That is again a good logic here. Let us assume this is a 3 sum, that is 1 and 2. If this is a 5 sum, why it cannot be 1 and 4? Why it cannot be 2 and 3 but 1 and 4? The moment you have this 2 and 3, this 3 contradicts the box 7 and there is no 3 in box 7. So always for 3 and 5 it has to be 1 and 2, and for 3 it would have to be 1 and 4, 2, and for the 5 sum it would have to be 1 and 4. So the only possibilities on the arrows are 1, 2 and 4. So this is not a 4, of course, yeah, right? Yeah. Amazing. As you can see, we have solved till this. Okay. So which means now we know that both of these cells would have to be 1. Both of these cells is 1 in any order. If either this is 1 and 2 or this is 1 and 2, and the other would have to be 1 and 4 and 1 and 4. So both 1 cannot be in this plus sign, 1 is not here, 1 is not here, so this cell is a 1. And we know that 6 would have to be somewhere in this arrow, so this is a 6. That gives you a 7 here. That eliminates 7 from these two cells. Amazing, right? Okay. And the moment you get a 6 here, 6 cannot be, okay, so we already have 6 there. 6 is in one of these two cells. 6 cannot be here, 6 is in one of these two cells. A pointing of 5 is in one of these two cells, so which means 5 is in one of these three cells, right? Okay, so the bottom part of the Sudoku is mostly done. For 6 it would have to be 2 and 4, for 8 it would have to be 3 and 5. Whatever be the case, you need 2, 3, 4 and 5, and for the 8 sum it would have to be 3 and 5, for 6 it would have to be 2 and 4, right? Okay, and now we'll go with the top right of the part. This is also quite tricky, and here what is the maximum sum, minimum sum you can get on these 6 cells is, let us count this as well, 7 cells. For these 7 cells it would have to be 21, or maybe let us take for 6 cells. These 6 cells would have to have the sum as 15, right? Now that's an amazing logic here again. The sum of these 6 cells is 15, which means you can still have a 16 and both of these can be 8 possible, and it can still be a 15 and these cells would have to be 7 and 8 in any order. Now I can say that 16 is not possible. Some of these 6 cells cannot be greater than 16, of course. It would either be 15 or 16. There are only 2 possibilities. 15 is possible, you can get a 7, 8 pair. What happens if the sum is 16? Both of these would be 8. But what happens here is both of these would be 6. If both of these are 8, both of these would be 6, and that gives you a contradiction. If at all we didn't find this as 7, if at all this was not a 7, this was a 6, 7, 8 pair, 6, 7, 8 triplet, then both of these could have been 8, and then the contradiction was not here logical here, right? So which means this finding this 7 was really a key to getting to the top right, and then both of these cannot be 8, it would have to be 7. So which means some of these 6 numbers are 21, some of these 6 numbers are 15. So this is 0, this is 0, and this is 1, 2, 3, 4 and a 5. These 3 are 6, 7 and 8 in any order. Of course you cannot have a 6 here, you cannot have a 6 here. So this is 6, this is 0, this is 1 or a 2, that gives you 7 or an 8. Amazing logic, right? Amazing. Now this is not a 0 and this is not a 0. This is either 1 or a 2, that gives you this as 7 and 8. This is not a 6. Now both of these are not 6, so this is a 6 here. As you can see, 2 0 and 2 0, you get a 2 0 pair here, 0 and a 2 pair. 3 would have to be in one of these 2 cells, pointing of 3s. Now this is 2, that is 8. Come on. There has to be something that we are missing. Let's see what we are missing here. Pointing of 7 in box 2, 7 8 pair and 7 here. and there is a 7 8 pair here as well. So this is not 7 and 8, so this is a 7 now. That gives you an 8 here, 6 and 8 here. Amazing. And we know that there has to be a 5 on this line, either on this line or this line. There is a 5. Okay, so let us write first this 7 and 8, 8 7, and this is 8, and this is 8, that is 7, that is 6, and that gives you a 6 here, a 5 here, and this is 1 and 4, this is 3, this is 1 and 2, this is 2 and 3 in any order, this is 4 and 5 in any order. Okay, and this is 7, so that gives you a 1 here, and that gives you 4 and a 1, that gives you a 3 4 pair here, that gives you a 5 and a 2 pair here, that gives you a 6 here, that is 7, this is 1 4 in any order, that gives you 3 and a 4, that is, oh sorry, this is 2 and a 1, so this is 8, right? So this has to be 5 and 3, and this is 4 and a 2, 2 and a 4. Amazing. Okay, so now we know that 2 cannot be here, so this is 2, and that is 3. So this cannot be a 5 now, because that would sum to 9, so this is a 5, and that is a 4, so which means this is 8 7, 8 and a 7, 8 and a 7, right? It's 1 3 4 0 2 5, so this is a 5, that is 4 and a 6, this is 5 2 and a 5, that is a 5 here, so this would have to be a 5, 0 5 and 3, right? 0 3 and a 5, so this is 3, that is 2, this would be 1 2 and a 4, right? And with that, this is not a 0, that is not a 5, that is not a 2, one 3 and 4, so this is 3, that is 1 4 in any order, this is not a 3, one 3 1 4, 1 3 and a 4. For the 7, 1, no, that is not, if there is a 1, okay, what are we missing here? There has to be something that we are missing. Oh, 5 has to be in one of these 3 cells. This is not a 5, so 5 is in one of these 2 cells, so this is a 3 0 and a 5, that is 2 and a 0, this is 2, 2 5 and 1, 1 2 and 5, so this is 5 and a 1, 4 1 4 1, 4 and a 3, that is 1, 3 and a 4, 1 and a 4, and 2 and a 0. Is it right? I am not sure. That I have written of 2. Oh, there are already 4s here. There has to be an 8 and this is nothing but an 8, of course. Sorry, that was my bad. This was not 4, this was 8. And yeah, with that we complete this amazing Sudoku by Akash Doulani. As you can see, it was totally logical but quite difficult. Of course, a 100-pointer Sudoku. It was 1 or 2-pointer if I'm not wrong. Yeah, it was 1 or 2-pointer, but it was an amazing Sudoku. Purely logical. There was nothing like very complication. I would say kind of a trial and error or some complicated logics here. But it was purely logical. So thanks a lot, Akash, for such a wonderful Sudoku. I hope you all enjoyed this Sudoku during the contest as well. And those who have not got the perfect exact logic, this was the logic. You had to go from the bottom left to the top right, and that's how this Sudoku gets solved. So I hope you enjoyed this Sudoku. Do like and comment if you want us to solve any other Sudoku variant or a puzzle genre, and don't forget to subscribe to the channel. Thank you.